Right, let's look at one last example of a hyperbola. In this case, if you want to find the foci, vertices and asymptotes of that hyperbola, 4x squared minus 16x minus 9 squared is 20, we're also going to sketch it. So, the first thing to do, as with a parabola and with an ellipse, is to complete the square, or the squares. And so we complete the squares and we write it in standard form. So in this case, we're going to get x minus 2 squared over 9 minus y squared over 4 is equal to 1. Right, so you just complete the square for x, and there's nothing to complete for y, and you write it in standard form. Right, and then you get this equation. Right, so let's call this A. Right, and now we're going to look at a hyperbola which is very similar to this one. Right, we're going to look at x squared over 9 minus y squared over 4 is equal to 1. Right, so we look at this parabola, right, this hyperbola, because our original hyperbola is just this exact one shifted 2 units in the positive x direction. Right, this x minus 2. That just shifts this whole thing 2 units in the positive x direction. Right, so let's call this for convenience B. Right, and now we find the features for B. Right, so for B, we have A is equal to 3, B is equal to 2, right? Because we have an ellipse of the form x squared over A squared minus y squared over B squared is 1. Right? And hence C squared is 9 plus 4, which is 13. So C is root 13. Right. So, now we can calculate the vertices, foci, and asymptotes for B. So foci would be at plus or minus C 0, and C is root 13. Right. The vertices, that would be at plus or minus A, and in this case A is 3, so plus or minus 3, 0. Right? And the asymptotes would be y is equal to plus or minus B over A. So plus or minus 2 over 3x. Okay. So now to get the features for A, we're just going to shift everything 2 units in the positive x direction. Right? Because that's the only difference between the two. This one is just this one shifted 2 units in the positive x direction. Right, so for A, what do we have? Well, our foci, we're just going to shift it 2 units in the positive x direction. So foci would be at 2 plus or minus root 13, 0. Right? Our vertices, those are going to be at 2 plus or minus 3, 0. So at 5, 0, and at minus 1, 0. Right? And now our asymptotes, right, we're going to shift these lines 2 units in the positive x direction. So it's going to be y is equal to plus or minus 2 over 3 x minus 2. Okay. So we have y is 2 over 3x minus 4 over 3. therefore y is minus 2 over 3x plus 4 over 3. Right, so those are our asymptotes. We just shifted the asymptotes for b 2 units in the positive x direction. Right. So now let's sketch this thing. Right, so let's indicate our vertices. Our vertices are going to be at 5, 0 and minus 1, 0. So let's see. 1, 2, 3, 4, 5. And minus 1. Right? And let's sketch in our asymptotes. Well, they're both going to have, they're going to have y-intercepts plus 4 over 3 and minus 4 over 3, right about there and there, and their x-intercepts are going to be over there at x equals 2. Right, so let's sketch them, and let me sketch them in a different color. Like that. Right, so here we have our asymptotes. Minus 2 over 3x plus 4 over 3. And here we have y is 2 over 3x minus 4 over 3. Right. So our ellipse, our hyperbola, so something like that. And like that. Right. And now just to enter our foci, 2 plus root 13. So, well, root 13 is somewhere between 3 and 4. So, 6 and 5, so it'll be about, say about, yay, that's 2 plus root 13, and then we have 2 minus root 13. Right. And that's the hyperbola, right? So remember, always complete the square, right? Find the equation for a conic section which is centered around the origin, for which your conic section is just a translation. And then find the features and shift them. Right.